What is up? I hope you're all having a good day. Today we're going to be having a look at this question here. As per usual, if you want to read it, you can just pause it, but I'm going to go ahead and get a move on. So I'm going to draw it out here. So we basically got one particle, the 8 kilograms, is connected to a pulley which has two other particles on it. And the idea is that you're trying to find the acceleration of that 8 kilogram pulley. And there's just a quick visualization of what would be happening here. So if we zoom in on the 8 kilogram, it's going to have its own weight force pulling it down. It's mg, mass times gravity. So it's going to have 8 g's pulling it down. But then if we split that vector into its component parts, we're going to have one parallel and one perpendicular to the surface it's on. And we know that that angle is 30 degrees because the slope of the ramp is 30 degrees. So you've got mg cos 30 and mg sine 30 to find the perpendicular and the parallel. So when you multiply that out, you've got 4 root 3 g's and 4 g's. And now we know that the restorative force, the one that's pushing off the ramp back, keeping the 8 kilograms from moving, is the same as the force perpendicular, which is 4 root 3 g's. And then the friction is mu times r. From the question, we know that mu is 1 over root 3, so that multiplied by 4 root 3 is going to be 4 g's. And then the final force is the tension force. That's what's pulling it, what's attached to the pulley that is attached to, and so the body's going to be accelerating in that direction. You know that the sum of the forces is equal to mass times acceleration. So the tension is pulling it in the same direction as it's that is accelerating in, so that's positive. The other two forces, its friction and the parallel force, are both pulling it away, so those are negative. Then if we look at the rest of this, we've got all of these weight forces that are pulling these down, but we also have their tensions in the strings. So you got the tension on the 2 kilogram pulling it up, and the S is the other string because there's two different strings pulling the 2 down and pulling the other 2 back up. So then the 2 is going to be accelerating downwards, the 3 is going to be accelerating upwards with a different acceleration, while the 5 is going to be accelerating downwards with that same acceleration. So if you do the same like we did for the 8 kilogram, we're going to try and find an equation for that acceleration. So we've got 2g plus 2s for the 2 kilograms. Those are both pulling it downwards, the tension from the other string and its own mass, minus t, that's the tension from the other string attached to the 8 kilogram that's pulling it back up, is equal to its mass times the acceleration, 2a. So then for the other two, we've got, for the 3 kilograms, we've got s minus 3g is equal to 3 times b minus a. So that's going to be the tension in the string that's pulling it up is the same direction as its acceleration, but its mass pulling it down the opposite for the 5 kilogram. So now that's b minus a, because it's going to be moving down while it's attached to the 2 kilogram pulley, but moving up because it's attached to the 5 kilogram pulley. So it's got some acceleration going upwards from the 5, but more coming downwards from the 2, pulling it down from the total mass. So its net acceleration is going to be downwards, but it's going to have some going up and some going down, so that's why it's b minus a. You need to account for both, and then use the same for the 5, but because it's accelerating downwards with both, it's b plus a. So then if we write out our equations for each of the different masses, we have t equals t minus 8g is equal to 8a, 2g plus 2s minus t is equal to 2a, s minus 3g is equal to 3 times b minus a, 5g minus s is equal to 5 times b plus a. We're looking for a and b, so that's what we want to find, a and b. We don't want any tensions because the question isn't asking for those. So if we want to cancel out all the tensions, so if we take c and d, they cancel out each other, so then we're able to find an equation in g that has a and b as variables that we're trying to find. Now this is where it gets sort of tricky, because you want to cancel out the t's and s's, but if you look at a and b, those t's cancel out each other, but then we're left with 2 s's, and then we have 2 s's in the other ones, but the c is positive, so we need to multiply that by minus 1. So if we add a and b, take away c, and add d, then we will have an equation which will cancel out all our t's, all our s's, and just leave us with g's, b's, and a's. So when you write out all of that, you're going to be left with 2g is equal to 18a plus 2b. Okay, so if we take those two equations we have in b and a from our two equations, where we have a simultaneous equation, we multiply one of them by minus 4, so we cancel out our b's, we're left with minus 6g is equal to 78. We can solve that to find a is equal to 3 over 35 g meters per second squared. Now, if you want to find the actual acceleration of any of the particles, you can find B. You just sub that A in and solve for B in terms of G. Then you're able to find the actual acceleration of any of the particles. Just remember B minus A and B plus A for the 3 and the 5. Thank you all so very much for watching. If you've got any comments, just throw them down below. I'll read them all. And if you want to see anything specific, just throw it down below and I'll do a video on it if I'm able to. Yeah.